All right. So what did you talk about last time? Man, you're supposed to send me an email, right? All right. Anyway, so last time we saw, how we kind of sort of, hammer out entities that we have to keep track of, and that each entity has what? Attributes or columns, right? Entities become relation or table. And then in each table, we keep data in row column format. The columns are the attributes, and they have domains, right? There are domain constraints on them. So what kind of data they can actually intake in there. And each row, we understood they represent a person. Then we also looked at how one relation or one table is related to another table, right? We did all those. Today, we're gonna talk a little bit more about the primary keys, how we choose them. And we saw last week that we should not choose primary keys that is comprised of what, like 2 or more columns, because that makes search harder, data entry harder and everything like that. We try to choose a single column, but now we're gonna look that, okay, there are some keys, like let's say the citizens database in the US, the natural primary key that uniquely identifies each person in the citizens table is your social security number, right? So that's natural. So naturally, we can use that as a primary key, but that's naturally. But the problem is with these natural keys, sometimes they are like, it's comprised of how many? 2, 5, let's say, 3 digits, then a dash, then 2 digits, then dash, then 4 digits, right? It's a long things to keep track of. So this is why sometimes we avoid the natural keys, even though they uniquely identify somebody, because you have longer character sets, you can easily make mistakes. You're typing somebody's social security, you can just bam, 1 digit, just off, it can happen. This is why we start choosing, actually generating, so to speak, primary keys as serial numbers, okay, or create new primary keys as we see fit. So that's what we're going to talk about today. We got this, let me just this. Okay, last lecture, we did all this. In this lecture, we're going to talk like key constraints, the natural and surrogate key. We just talked about natural key a little bit ago, and then not null and not null, and entity integrity constraints. All right, we know the constraints are rules, limitations that we have to follow when we design our data, right? When we do our data model. So let's look at all these constraints. We looked at primary key constraints, and we looked at domain constraints. Some fields can have only characters, some fields can have only numbers, things like that. Okay. All right. In the relations, a quick question is, can a relation have many keys? Okay, explain how. If I did not say, it did not say primary key, so I'm guessing all kind of keys would fall into that, right? So Tyler, can you, thank you. Foreign key, there can be foreign key in the relation that points to some other table. We saw section numbers point to section table in a grade report table. And so we can have multiple, and then again, we also can have, candidate keys, right? We looked at the VIN number plus the tag and state. So VIN number uniquely identifies a car. At the same time, tag number and state can also identify a car. So both these sets are candidate keys. From there, we chose the VIN number because it's a single column thing. So that's why it's easier to use that as a primary key. So you can have multiple keys in it. But the thing is this, can 2 rows in a table have the same values in the key columns? Depends. If it's foreign key, it can be duplicated, right? Like 2 students can be taking the same course and get grades in there. So grade report will have the foreign key, which is the section number, that may be duplicated. But if it is primary key or unique key, you cannot have duplicate values in there, right? Let's say citizens database we created, we decided that social security number is a long key. We're not going to use it as a primary key. So we're going to generate a serial number, 1, 2, 3, 4, 5, 6, and we're going to go as far as we need to go. But we have to ensure that the social security number, even though we did not use it as a primary key, it has to be unique. Database must ensure that uniqueness is maintained. No two citizens will have the same social security number. So that's what we have to keep this in mind. All right. So here, the student number, you cannot have two student numbers for the same two people. Same student number for two people. So natural keys, we just talked about it. Natural keys are keys or attributes that come naturally for any entity, which may be able to identify each rows or records, right? So, like I said, social security number is natural key. So here we looked at the VIN number or tag and state. So these are, naturally they're part of the data, part of the entity, and then you can use them to identify each entity. And then social security number for a student. Okay. However, sometimes look at these key points. These are very important. We do not use natural key because I can't even talk today. They may not be good choice to be a primary key because they might be either too long or they might need more than one column or, okay, so like here, employee, first name, last name, title may generate a primary key, but we are not going to use it. Too many keys. Also, it may be duplicated because many people have the same title, same first name, same last name. Or a natural key may be too long. We just talked about this. So we're not going to use that. Here, this is a very important point. Natural keys may be a lot of time very sensitive data. Your social security number is very sensitive data. You don't want it to be exposed to everybody. Primary keys, sometimes you have to expose to be able to search quickly or something like that. So this is where we just kind of hide that. Social security number, we're not going to show it as a primary key. So we're going to use our own keys. We're going to generate keys. Okay. Okay, this is where the surrogate keys comes in. This is the serial number or our own schema, own method of generating primary keys, ensuring that each of them will be unique. Okay, this is what is called surrogate key. Surrogate key is not part of any entity. Naturally, they don't come naturally with the entity. When I say person, okay, the serial number that identifies the person is not natural to them. A person is a first name, last name, title, address, phone number, things like that, right? So to identify a person, we may create a person ID with our own method, or tell the database that you generate serial numbers for each person. 1, 2, 3, 4, 5, 6 is going to increment like that. The thing is, surrogate key benefits is, especially if you leave it to the database to generate it, it will always make sure that every row has a unique value in there. They usually tend to be small, easy to do. Yes, sir. It's a primary key. Of course, it's a primary key. But the thing is, it's not natural to the entity set that you're working. Say that again. Yes, it's actually, ordinary users don't care about that. It'll be like in the database will ensure that these are unique. And when we program, you'll see in application programming, you'll have to use that. Or when we query two relations together, like we did, we found out what Brown made in data structure. To do that, we use the foreign keys to relate them all together. That's when they come in handy. But it doesn't have to make sense to regular users. And it's not natural to the nature, remember that. This is something you're imposing on it, on the entity that you're dealing with, okay? Is that clear, Tristan? Yeah. All right. So, the unique identifier that is created to identify each row in a table. So, it's a primary key. Often, there's your answer. Often, no obvious, meanings to users. It's 1, 2, 3, 4, 5, 6. What is 5? Who cares? Okay, no, but programmers will care, the database will care. Not derived from application data, blah, blah. This is, we do not derive it from application data. It doesn't come naturally from the entities. Okay, like a social security number is a natural attribute of a citizen. We are not going to use this. So here, this is what we do actually. Usually, we leave it to the database. Say, hey, dude, you generate. Anytime I enter a new record into this table, you're going to generate a serial number for it. This is what is called in MySQL auto increment. It starts with 1, or you can specify what value it should start at. It may, the first record, it may give it 100. And the next record, 101, then 2, 3, 4, 5, 6, 7, 8. Oracle uses sequence numbers, and identity column is used by Postgre, MySQL Server, things like this. So you can specify. We'll see. We'll start working with creating tables, because we're now finding out how to create tables. What we have to consider in this now, and practically, we have to actually create tables to see how all this are put together. Okay. Oh, another thing is this. A lot of time you'll see that sometimes we generate surrogate key based on particular, aspect of a product. Let's say you're talking about a cell phone. So CP. Sometime I may use those 2 letters CP to indicate it's a cell phone, right? And then maybe which warehouse it is in, 001, something like that, and then something. When we do it this way, we are embedding meaning inside the primary key. We should not do that. It's dangerous because you know what? Anytime this product may change, some things may change, some of those attributes that we are using as part of this primary key may change. Doesn't mean you have to change the primary key, but that's dangerous. Changing primary key is a dangerous business. You know why? Tell me, Heather. Tristan. Very good. Because it may be related to some other table, right? Now you have to change it everywhere else. Right, Mino? Mackenzie? Bradley? All right, Mr. Rastos. Anything to add? Yeah, exactly. You think about this. Your phone number, if it changes, how much trouble it costs for you. You have to tell everybody, hey, look, my phone number is not this anymore. I mean, think about it like that. Tyler, Dumas? No? Any questions? Anybody else? All right. Let's go. Okay. The thing is this, we know that there are some keys that come naturally. Naturally, they're unique, attribute of an entity. So, but we are using surrogate key. We're generating our own primary key. What will happen to those natural keys? What do you have to ensure? Uniqueness, because it's naturally unique to an entity, right? Social security number must be set as unique when you're creating the table. You must say to the database that, look, social security number is not a primary key, but I want you to make sure that it is unique for each individual. You won't allow anyone to enter 2 persons' information with the same social security number. All right? Okay, we have to do that. Okay. All right. Which one is the number 3? Can someone tell me? At this point, we're supposed to do some in-class exercise. Let's. All right. Okay, it's due on 24th is today. It's a lot of things, but you're supposed to, should we do this in class? Okay, let's do this. I'm gonna talk less right now. See if we can figure out. All right, look at this. What is the description given? Following table, teaching schema. You know how we, specify schema, right? The name of the schema or the table or the relation of the entity. And then in parentheses, we put the attributes of the columns or the fields, right? Like here, we get the teaching table, prof ID is a column which contains an integer. Then we get course code, whose domain is varchar or variable characters, 0 to 6, up to 6 characters long. And the semester year, which is a varchar, up to 10 character long, it can take. Okay. So if we're looking at this schema, you can tell what type of data will be in this table. Okay. What we'll do is let's do this. Let's open up Microsoft Word like last time. And what are we gonna? We're gonna just create this table. It has how many? 1, 2, 3, 3 columns, right? So let's insert a table here. Columns with some values in there. This is prof ID there. And then course something, I forget what it is. Anybody remembers what it is? Course code and then semester year, right? Course code and then semester year. All right. Prof ID, let's say it's 999. Course code, let's say CS. Oh, why CS? Why not COMP2200? And then you get semester year, let's say 2022, fall 2022, right? Okay, then you get another CS 1301, let's say, and this is fall 2022. This is like the table C. Now I get another course, let's say, it's called CS 3820, let's say, blah, blah, blah. Okay, so this is what our table may look like, all right? So now let's work on this. Which keeps track of what course is taught by which professor in which semester and year. So this table telling us in which semester, which course was taught by which teacher, right? So a course may be co-taught by multiple professors in a semester year. Okay, only one section of the course is offered each semester. Okay, Tyler, remember this, because you know, no, that's good. We should, in real life, you have to. Here is the thing. For simplicity's sake, we are saying only one section is offered. That's why we don't need to keep track of section data here anymore, right? One section of a course is offered. That's the, business rule right now. Okay, we've got to follow that. So why did I type all this in? There's an example right here. Dang. A professor may teach many courses in any semester, but remember this: two professors may teach the same course. How is that possible? It's very, huh? No, professors, if you call them teachers, they'll be angry with you. Here's, let's say in this database course, right? I'm talking about how to structure data and how to create the schema for the data and how to put data in it. All these things I talk about. But database security, I'm not an expert for that. All right. There is a professor here who is an expert in database security. He may taught that part of the course. Trust me, that's what happens. Our university is not that huge, but if you go to MIT, if you go to Georgia Tech, we had a course, computer data network security. There are 3 parts in it: computer security, network security, data security. There was a university. In an university, there were 2 professors teaching it, because one was expert in data security, the other one was in network security. So they taught those 2 parts separately. So it can happen. So anyway, just a side talk, off topic, So this is the table. Now, please answer the following questions. Logically thinking, what should be the primary key of this table? To determine the PK, please do not rely on the data below, as the data below violates constraints on the database. You will need to consider the above description of the table, blah, blah, blah. So first you have to think, what can I use here as a primary key? Is it possible to have a primary key here? So professor ID is, but it's not. No, but Mr. Rastus, professor ID is being duplicated here. if you say that, because one professor may take multiple courses.
No, it says not unique.
Okay,
For
okay.
the course.
So, yes, Tristan.
Data, so they want an entire, because primary, obviously, it's all three attributes, because you can't look at.
Okay.
More than we can.
All right, all right.
Technically, you need this professor to teach
Okay.
courses, and also course code, semester year. Those aren't unique either, because those are taught by one.
Mino, did you try to say something? Mino?
I think oral or treatment cannot private.
So you're agreeing with Tristan that all of them should be used? Or no?
If you want to make primer key by using the table, you should use oral contributors.
Okay, so we agree on that. Tyler, Mr. Rastus, that if we use, Bradley?
I think you can just use the first two, because if there's only one course, like one section taught,
Ah,
then couldn't just use the first two.
you know, I kind of,
They could teach the same thing.
what do you
next
think?
year.
What do you think?
They could teach the same thing next year, right? And if you duplicate it, same section. I'll be reading.
That's a good question, because different semesters, you can have the same professor teaching the same course. Then it's a very good point. See, this is why I love discussions, you know. But Bradley, that was kind of, you almost convinced me. You know what I'm saying? But this is how we work in the team. You know, we have different perspectives. And the thing is, so in a, you know, different semesters, same professor, same course code. So those two cannot be used. You actually have to use all three, just like Tristan and Mino said. Okay, if you use all three of them, then you're going to have a unique key, but it's kind of terrible, isn't it? But looking at it, it's just, you have to match 3 columns to find somebody. It's going to be a pain on the database. All right. So given the primary key you specified, does the following database instance violate any constraints? If it does, what constraints does it violate? Can somebody tell me? It is saying, okay, now you decided on a primary key based on all these 3 columns, right? Is there anything that's violating constraints? Which one?
It's not an integer.
On the first column, yes, second row.
Okay, so okay, yes, this is actually a mistake, right? Heather? Because this is, it got a P in there. It should be 23 only or something, right? That's a problem. Another problem, can somebody notice? I mean, Mackenzie? Course code for? Math 3090. No, that is okay. You know, it's a course code.
Course codes.
It says 26 characters.
Huh?
It's been 6 characters.
Oh, okay, thank you. All right, good catch. Thank you, Mackenzie. And thank you, Tristan, for verifying that. Now, isn't there something else wrong, Tyler? Row 1?
So use the alter of them as primary key does violate that. One row, rows 1 and 3 are equals.
Ah, same data is, you know, it's duplicated, right? Same thing, because Professor 2 teaching CS 3230 in fall 2008 is duplicated here. That's the problem. There's another problem here. Talk to me, man. Very good. Very good. No, because it's a primary key. You're saying primary keys cannot have null values there. All right. Yeah, good. All right. So these are the violations we looked at. Now, so one constraints the not null violation, not null, and then the uniqueness, are violated. Okay, and then it should be all integer for Professor ID. That's stuff. Okay, so we got all these. So that means, that tells us it's dangerous to use all these 3 columns as a primary key. This is time for surrogate key, right? Generate your own key. 1, 2, 3, 4, 5, 6, and it'll look really nice. Okay. And then we get this, given the following tables, please identify if a surrogate key is required and why. So we got, what is the name of the table, first table? Meeting. So we got, in the meeting, we got student name, which is how many characters it can have, max. Very good. So, and then advisor name, how many characters max? 50. Date time is what type of data? Exactly, it gotta have a valid data in there, date in there. Then we get the description, which can be up to 100 characters long. What we discussed in the meeting, blah, 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 things like that. And then we get voted. Voted. Okay, we get the voter ID. I'm right here. Oh, this, you know what? I need to make it a little bigger, don't I? If I just look at there, it's just like tiny bit, Okay, so is it better now? Yeah. All right. So voter, we get voted. That's a table. It keeps track of, which people have voted for which candidate. All right. So you got voter ID that identifies us, people who anyway, a candidate ID for, whoever the candidate and the position and the vote date time. Okay, when did you vote? All right, so it keeps track of who voted for whom and when. All right, and for what position. Note that a voter may vote for a candidate in different years. All right, what does that tell me? Yeah, I'm like, this year's student council election, I voted for Tristan. Next year, I voted for Heather. Next third year, I voted for, Tristan again, Okay, first read through this description. Okay, so note that a voter may vote for a candidate in different years. So same candidate, same voter ID, same candidate ID may be duplicated, right? For different years. All right, on one ballot, there could be multiple candidates running for different positions. Therefore, one may vote for many candidates at the same time. What does that supposed to mean? Louder. Okay, so let's look at this. First thing says, okay, let's just create this table because this table needs to be created actually. That way, we can. What happened now? The voter ID, the table there. Let's say, how many columns I need? 4 columns, right? Let's sound like this. Okay. Oops. All right, so let's say here voter ID, let's say 1, 2, 3, 4. This is 1, 2, 3, 5, let's say. And then 1, 2, 3, 3. And then we may have duplication, 1, 2, 3, 4. Candidate ID, let's say 90 and 91. This guy voted for 90 as well. And this person voted for another candidate. Remember, that's what the second rule is saying. The Rush rule says that you may have multiple people on the ballot, right, for different positions. So all those you have to keep track of.
But your voter ID, you have to say, you can't have it. Your voter ID.
No, but when you are actually, what it says here is that, let's say you are trying to elect a committee, right? The committee has its, the main person. Then you get 4 other members, let's say. So they are listed in the same ballot for different, people. And which members you chose in the ballot? You can choose, 4 different members and the main person, right? Okay, so that's what it is saying actually. In this table, all those records will have to come in. Let's say this guy, candidate 90, is running for president, right? 91, he was running for president as well. But line 90 here, yeah, of course, president. But this year, 95, let's say, he was running for secretary position, okay? What date and time, forget this, okay, with some dates and time. So now you have other duplicates. See this 1, 2, 3, 4. This guy voted for this candidate and then also voted for this candidate, two different candidates on the same ballot. That's why their records has to be here. Who did I vote for what positions? Okay, so this is what it is. And line C133 may vote for somebody else. Voted 97, which is a secretary as well, let's say. Oops. All right. So is this data making sense now? Okay, so we get multiple, and if we have time, date and time, you will have different years. Stuff will come in like that. Okay, I'm just being too lazy. So this is our situation. So here, that means you can have in multiple years, you may have this data duplicated. Okay, why not just do this? So let's say this data is duplicated again. And this is in 2021, let's say, and this was in 2022. Because the rule says same person can vote for the same guy or same girl in different years. Right? Okay. So this is 2020, and let's say this is 2021 and 2021, something like this. So there may be duplication on that candidate plus voter ID. Okay. So now we have this. Now let's look at this. So this is the ballot that it looks like. You get many people running for many different positions, and then you get applicant, their assistant, blah, 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 inventory item. Oh, these are actually not related. Okay, anyway. So
That's where.
identify if a surrogate key is required and why for these two actually, right? Let's look at this first. For the meeting, do we need a surrogate key? Is there any natural attributes that are listed here can be used to identify uniquely a student? What do we have? Student name, advisor name, or in the meeting? Can a meeting be identified uniquely by any of these natural keys? Bradley? Okay, say.
A student name and the date and time, because the student can't be in two places at the same time. So if you use student name and
Good
the
question.
date together,
Is it? Rihanna?
you can't have
Agree?
two meetings at the same time.
Tristan?
I would raise that slide. Time slot like 11, 12, or is it like?
Oh, no, it will, since it says date time, you'll have both. 10 a.m., April 10, 2000. I knew Taylor will cause problems. What is it?
You could have two students at the same time.
Okay, this here we're gonna simplify. All right, simplify how? All students have unique names. All right, because this database structure is not proper at all. Because there's no unique identifier, right? The student name, okay. Based on that, we just we'll take it for granted that okay, each student have unique names. That's not actually right. Doesn't sound right, no. Okay, so student name may be duplicated, so we're gonna have a problem with student name and date and time. And I'm going with Tyler on this one again. That's a good question. That's a good question, right?
On the other question too, like I put student, I went through a graph, I put student, date and time. And that student, with that date and time, it causes everything to be separated. So I had date, time, and seconds. So no matter when that person appeared, it cannot be duplicate.
Okay, that's a design issue. Then if we restructure it like that, you're right. But right now we just have to deal with this mess. Okay?
Seconds, yeah.
Now, but let's say here it's gonna be, we simplify things. Date, and let's say 10 a.m., 10:30 a.m., 12 p.m. Okay? So if it's like that, now what can we use here to uniquely identify a meeting? Okay, this meeting happened on that day with this advisor and this student.
We can join the service.
So without the description, everything else,
We can join the two together.
two together, three together, actually.
Continent,
I'll say three, right? Yeah, we'll, you know, we can use this three, but there is a need for surrogate key. Why? Student name, advisor name, date time, it's a long data, multiple data. We don't need them, right? So we can use a generated key for that. Heather, you tried to say something. Oh, okay, thank you. All right, so we agree on that we have a need because we are having to use three different columns. And then like Tyler pointed out, you know, student name, heck, you know, it's no unique, right? So all this advisor name, not unique. We need all these three columns, so we hack with this. We're not gonna use these three columns, we're just gonna go with one. Now for this voted, now let's look at this table. All right, there. Okay, here's the deal. Let's say we have data like this. Now, what can we use? I mean, to uniquely identify somebody. Can voter ID be used? Because the same voter can be voting for multiple candidates and then his data or her ID will be duplicated, right? Am I clear on that? Is that clear? Like right here, if you look at this 1, 2, 3, 4 is showed up again here, right?
but that's the way it works.
Yeah. But does that uniquely identify the row? That's the question. Because if you say this row, 1, 2, 3, 4 uniquely identify rows, it is not because this is showing up in three different places. So it's not uniquely identify a row. It cannot. Since they're duplicated, right? Since it's duplicated. Now, question is candidate ID can?
There's like two different candidate keys to this. First, so you have candidate ID, position, and vote, date, time together, or you can have voter ID, position, vote, date, time together.
Huh?
Because someone can't run for president twice in the same year, right?
Exactly. Good.
So you have two options.
So Tyler pointed out two different sets, right? If you discuss more, you can find problem more. But anyway, two different, what he said, voter ID,
Position,
the position and the
date,
date time.
for the candidate ID.
Okay, candidate ID, position and date time. We cannot use the second set. Why? Because other voters may be voting for the same candidate the same date and time. Is it possible? Hey, let me do this. That'll be best. Okay, just create another row, just like this. Okay, this guy, let's say it's 7. He voted for this candidate for this position. So now if you use this is not unique. Is it unique? No, but it shows up in the row above it, right? So what was the first one? Tyler? Voter ID, position, and date and time, right? What no?
Change position and ID as well. Reset.
Change position.
Yeah, voter ID and vote date time.
Okay, yeah, candidate ID. Okay, we can do voter ID, candidate ID, and date time. What is the problem there? Is there any problem? I don't see a problem. Do you? No, let's not. Tyler, man, oh man. Tyler, you'll be a very good, software tester. You know what I'm saying? Find that all that. We had a QA team, the QA team and developers team, they just always fight all the time. Because they give us a worksheet saying, hey, something is wrong with this work order, fix it up. We fix it, test it out as much as we can, and send it to this lady, and she comes and, hey man, right hand is broken. What the heck, man? What is your problem? You fault finder. But anyway, that's what they're supposed to be. Because you don't want your client to find out the faults, you want your team to find out the fault. So you can, fix it up and send it out, your reputation, right? But imagine, this is actually QA team is very much needed in a, software development team, in software engineering team. They are your, how should I say, checks and balances. So they're your, sentinel, so to speak. They won't let you do something wrong. All right. So this software testing is a very, it got a lot of opportunities right now. If you guys can consider, even if you want to consider this, there are a lot of courses in Udemy, Coursera, places like that, a lot of training, places. You can actually do a 6 months course and start applying for jobs. There are a lot of jobs out there for this. And most of you can work from home too. The testing does not require you to be present at the spot. Okay, so here we decided on what? Voter ID, candidate ID, date and time, right? This can be. But again, we get the same problem, right, Tyler? We have same problem, Mr. Dumas. Same problem, right? Same problem is what? We're having to use 3 different columns for a key. So we need a surrogate key. So that's your justification, okay? Remember this, we're doing this exercise in this class right now. Doesn't mean you're not gonna fill this out because there will be zeros, okay? 24th is today's what? Today probably you won't get time, right? So I might change it to tomorrow. How's that? If you don't do these assignments, if you don't put it out there, if you don't submit them, I won't be able to grade them. Because I'll start grading everything this weekend. Everything up until now that we have, And then, sir?
We should put it in our upload it like this.
Not like this, just, justify why this table need a surrogate key. Surrogate key means a key that you decide, you generate or database generates. None of these natural attributes, this field, voter ID, candidate ID, blah, 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 none of these. You're adding, imposing a different one. That's the surrogate key. So you have to justify. For the first 2, you justify. For here, the applicant, the inventory item, you justify, okay? So all this, what time our class ends? Oh, 3:15, all right, cool. All right, so all these, the rest of these, I'm gonna leave it to you. We discussed a lot. I think we understood, the things clarified for us. Now, given the following table, let's look at this one. Stock, index ID, company ID, stock symbol. And stock symbol is not null, not unique, okay? The company may have different stock symbols on different indexes, but for a particular index, it has one stock symbol. Note that index ID represents the index that the company stocks is taking over for a given company. How many keys are there on this table installed? Keys as in candidate keys, Okay, so stock symbol, does it change for?
Unless it's.
Okay, company may have different stock symbols from different may have. So it's not like they will have. So they may use the same symbol for different indexes though. So
No,
stock.
They use the same symbol only after they have did a buyout.
Okay, that's in real life. But here we have a imaginary situation here, okay? So here what it says, the company may have different stock symbols on different indexes, but for a particular index, it has one stock symbol. That means the stock symbol will actually, either may be different for different indexes, may not be. So that's where our uniqueness is out the window, right? Everybody agrees? Oh, come on, man. Everybody getting tired already?
That's the tough one. Stock symbol stays the same, even for index. New York Stock Exchange, American.
I don't know much either, but just go with these rules that are specified here. That's that. Go with these rules. Okay, 2 keys are what?
For the first question, how many keys are there in the table?
Uh-huh.
So the primary key is index ID company, right?
That's what it says right now, yes.
Yes, you have candidate key, which is according to the second paragraph. No two companies that trade on the same index have the same stock symbol. So
So index and the stock symbol will always be unique, right? So those two can be used together?
well, those are the two. It's the one primary that we already have, and then the candidate key, which is could be a primary, but which is the underlying one instead, right?
If a row contains 3, 4, and null, does it violate any entity integrity constraint?
Yes.
Yeah, I'll say yes.
If you're using it as a part of your primary key.
Oh, yeah, on that, we also mentioned, like, where it's a stock system, that stock is not null.
Oh, it's not null. Oh, very good. So it's saying it's not null, but at the same time you're putting null in there, right? You're gonna constrain that violation. The constraint, violate that constraint. But also too, you're using that as part of primary key, so you cannot have a null there, right? Okay. All right, so we had a pretty good discussion. What are you gonna go? You're gonna go home and freshen your head up a little bit and get back on it. Complete this assignment and any previous ones. All those are done, right?
You haven't done any class exercises to do that.
Why is that? Sir, I changed the deadline for you.
Oh, I see what you're saying. Like, you're saying,
Oh, you're taking all of them from this person.
Yeah, because the
So we did question 1 and 2.
Yeah, 1, 2, and 3 are due.
All 3 of them are due today, right?
oh, yeah.
So I can, change it to, like I said, we had a shaky start. So initially I'll have to cut you some slacks, right? So we can change it to when? But it has to be done by this weekend. Is that cool? Huh? Friday? Oh, Friday? That works? Friday works?
What do you guys say? Right.
Okay, see, All right, but as we get more advanced, into more advanced stuff, we're gonna be tougher, all right?
Could I ask you a question?
Yes, sir.
So like with question 3, how do we submit it? Because I like to, table.
Tristan, can you, shed some light on that?
So like, so I've already turned to question 1, but let's say question 3. I'd like to always fill out tables.
So you want to add a table when you make the submission.
No,
Yes.
actually, it doesn't want any tables in here. It wants explanation. What do you think the keys might be? Why do you think we need a different key other than all these attributes that we have there? You just explain, you justify your answers, huh?
So in this case. Table.
Yeah, but if you create the tables like I did, it makes it easier when you have some data, then, hey, it doesn't make sense. It's easier for you to, get it done. So that's why, when you're doing it, draw a table on your notebook or in the Word like I did. Put some data, random data in there and see if things make sense or not. All right. It'll help you identify, the issue. Okay, so now that's cool. Now let's head back to the rest of our class. But let's take a 2 minutes breather, We have worked our brain a lot, right? Okay. Okay, so and now up until now, any things we, Heather especially, and many other students, like I said, because this course, this is the first course many people are taking. They're a core course. This way it's kind of like you got hit, bam, like that. And what the heck, what is going on, right? But is this getting better any? That's the question. We'll work with any concerns, any issues you're, having, you must discuss with me. Because the purpose of it is to learn, right? Together. If we can't fulfill that purpose, then we get a problem. And if you don't tell me the issues you're facing, then I won't be able to help you. All right. So that's it. And it doesn't mean that you're going to be lazy like Bradley. No, I'm joking, Bradley. Bradley is just deep into something, Anyway, probably watching a movie, right, Mackenzie? Anyway, it doesn't mean that he's just going to be lazy, and say, hey, I'm going to just do it. Last week I got an email from somebody that I could not set up the MySQL database. I don't know how to work with it. I say, after all these days, right? You should tell me ahead of time. Now you got yours going, so that's good. But you need to look how to import database. Okay, the world database you don't have. Whenever we go to virtual lab, it has the world database and stuff like that. But you'll see that on your local machine, when you install the MySQL, you don't have those world database, the Shakila database, you don't have that. You have to import that. It's very simple. Just do a search, importing world database plus MySQL, bam, you'll find a lot of answers like this, It's like Mino and I, we had to find it out, right? Yes, I am trying to, if I can get to it. So let's do this. Let's see, do MySQL plus import. You're gonna import because this is a database with data. The schema and everything is in there for you. You have to import it to your system, then you'll get the whole thing. Import world database, right? See this setting up world database. Right there. We get this. Setting up world database installation. You go there, you have to download it, of course, first. And then once downloaded, you download it from here. See that link right there? So you download it from there, then you just follow these instructions, Or this is using the MySQL command line where you type things up. But you can easily do import through Workbench. Very simple. Okay, they're like Workbench export, import, you'll have options like that there. All right. So I want you to go ahead and do it. Whoever installed the MySQL database systems on your personal system, personal machine, please go ahead and the Shakila, I don't know how the Shakila database plus the world database. All right, and you can do queries because they already they're pre-populated with data. So you can actually mess around with it and find out what you get. It's a good way to learn. Well, another important, there's a very interesting website. It's called SQL Zoo. If you go to SQL Zoo. Yeah, they already got some database for you. You can run a lot of select queries only. You cannot do insert queries. You cannot put data in, but you can read data. Like select zero, select basics, Yeah, there you go. See, there's this query right here. Select population from world, we're naming it to France. So there's a table like this. All right, this is called the world table. It has name, column, continent, area, population, GDP. So it tells you the names of countries, their population, their GDPs, and things like that, and their total land area. And then you got what continent they're in. So you can do all kind of search. You can find out how, you see, like here, this query will find out how many, what is the population of France? This query, if you run this, you'll see, if I submit SQL, see, France has, I'm not even going to try to, 659, that don't make sense. What is it? 659 million? Is it? And 6,000? Or no, it's 6,059,000, no, 65,906,000. Can't even read that. But anyway, then if you want to know, the total land area, what do? Instead of population, what column should I put in here? Area, very good. Area, then if you run this, we'll know the area, total land mass, that France has. Yes, sir. So here, this you want to know what the primary key is in this table, right?
Yeah.
This is the command you're going to run in MySQL. You're going to run describe, DESCRIBE, or short DESC, and then put the table name. It'll tell you what columns there are, which columns are primary keys. And in Workbench, you can easily look it up. It shows it on the side, on the left side, it'll show you what the primary keys are. That's SQLview.net. You go there, you can practice. This is like, already preset for you, pre-populated database, and you can run all sorts of queries in there, all sorts, interesting queries you can run. Look at this. This is a query, it uses a special, in operator. So they're saying, give me the population of countries, Brazil, Russia, India, and China. Then we got those 4 countries. If I take away China and India from here, what should I get? Only Brazil and Russia,
For
right?
the United States.
Yeah, of course. Why not? Okay, USA. I'm hoping this is the spelling is right. No, it didn't. So USA is spelled USA. Net.
United States.
Sheesh, United States, probably United States, right? See, it depends on how the data was entered. Yeah, you're right. Very good. Very perceptive. So, interesting. So this is start doing this. Don't waste time. Because the sooner if you start working on this, you'll get better at it, right?
How do you put stock?
Huh?
How do you put, let's say, in the stock market? How do you put where do you go to look at the stocks?
Oh, so it doesn't have a stock database. It only has a world table that lists all the names of the countries and their population. You can find this is what I can do. It's interesting. You can do select count, right? I want to know how many counts start from world, right? If I run this query, there are 195 countries listed in this table. That's what the count gives you. Count star means just count, each row. Count all the rows up and give me the total of it. So count. There's so many different types of queries. It's so powerful, SQL. It's very powerful. And you can also do sum. Let's say I want to do this. Look at this. This is the world's total population according to this table. I did a sum on the population column. It added it. So anytime you have a column that's numbers, you can add them up like that using the sum. All right. So sum is we call this aggregate function. They aggregate the columns, information in there, and put them together, gives you a summary. And you can also do this interestingly.
Like average population.
AVG, yeah, of course, AVG. Look at that. You get an average one. And you can do this too, interestingly. If you want to know the max population, I can't even spell anything. The max is this, but you don't know which country it is. How would you find it out? Look at this. So you do this. Max population, comma, country. Oops. But you run into a slight error here. If I do this, I'm supposed to get the country, the column country in value. Oh, name, sorry, my bad. So this is name actually, not name from world. If you do that, you're gonna give you an error here. The thing is, whenever you use aggregate functions like this, along with it, if you use any other columns, you kind of have to, put that column in a group by. We'll learn all this later. All right. So this gives you population. We'll look at all those populations. Did I misspell? All right, now you know what? Let's not get into because I have to use what we call it aliases here. We'll do this queries later on. Okay, so let's not get up on the
Question, can you import into this workbench? Import
Oh,
spreadsheet?
these days I don't know if they allow you to download it or not. If they-
Can you import spreadsheet into workbench?
No, not directly. No, because it is not designed for spreadsheets. You work with Excel a lot, right?
Yeah.
How much Excel do you know?
Basically. 50-60%.
That's good. Excel is a very powerful tool and it's getting more powerful every day. Anyway, so we'll do all this. Let's go back to our lecture. So not null constraint specifies null values are not permitted or permitted. So not null, not null tells you if a column may or may not have null values. Not may, should or should not have, must or must not have null values. Okay. So nulls are actually very problematic to deal with because it's nothing. I mean, it's not defined. It's something, it's not zero, it's not empty. Okay. And always when you have null column, this is why when we do data analysis, what we do is that we actually take care of the nulls first. This is called the cleanup stage. In the cleanup stage, you remove all duplicates, and if there are null values, you change them to something understandable. So this is easier to deal with. But you can have null. There's a lot of time when people collect data and enter data into database, they forget. They forget to add values for certain things. Okay. So if you say this column cannot have null, you won't be able to put null in it. It will violate the constraint. Just like Tristan pointed out in one of those, Okay. So look at this, how the problems occur. In this one, the grade is null. Somehow somebody put in a null. That means when this table was created, I did not specify that, hey, grade cannot have null values. If I did, then database would have stopped from entering, leaving it, empty. Okay, a query like finding all the students whose grades in CS 1, 2, 3, 4 are not A will not return the row with null. So this query right here, you are doing a query to find out all those students who do not have an A. In that, unfortunately, you would think it will return all this first row and the last two rows, right? But unfortunately, it won't do that. It will only return you the B and the C, first and the third. The null, it will ignore because it cannot compare the null with A, B, C, okay? That's a problem. That's why it says, hey, heck with it. So they will, it'll ignore it. And then if you count grade, it will return 3 instead of 4. Because you say, hey, grade column has nothing in it. So I'm not going to consider this row as part of this, so it's going to return 3 to you, not 4. So this is why you should always deal with null when you're dealing with data analysis and things like that, okay? Okay. All right. This is some more formal, things. So schema S, we know schema S, schema contains all our table definitions of all our tables, right? I may have 4, 5, 10 different tables. All those tables, their definitions and their constraints together, we get the schema, right? So a schema is defined formally as with capital S. All right. So a capital S or schema is actually a set of tables, right? Tables are relations or entities. Agreed? Okay. So S is actually a set of relations. It depends how many relations or tables you have depend on your system. What are you trying to, create the database schema for? So it depends on that. And then entity integrity is the PK attributes of columns cannot have null values. It must. This is called the entity integrity because you won't be able to identify records if they have nulls in their primary key column, right? We agree on that? Okay. Okay, so read this. Other attributes of R may be not nullable, even though they are not members of the primary key. Here, if you look at this, if we have a student, we never want their name to be null, do we? How gosh, you just took my name out. Can't let that happen, right? So we will have a not null constraint set for this name column, even though it's not part of our primary key, right? That's what it means, this note. All right. Remember, all these things will help us create, we're going to start creating tables, databases next class. All right. And we're going to start working on how to create tables. Okay. All right. Unique constraint, we have already talked about this too. In the citizens database, we got social security number, which should be unique, even though it's not the primary key. So it's a unique constraint, right? Okay. And then we come to our next exercise 2, which you will try out at home. Okay. Why does it say 2? Which mechanism? It says 2. Oh. This. How to do it?
Yeah, talk about that. Because we ran class last time.
Oh, then come on, man. Why did you remind me of this? Okay. Let's have a quick look. Oh, it's pretty descriptive, you know.
Oh, yeah. Interesting.
I tell you what, and now go ahead, try this out because you know she gave us a step-by-step instructions here, so you won't be able to mess it up. Try it out. Okay, let's do it, submit it. I'm gonna change the due date to Friday, right? Do it, submit it. And then if we see if there's issues with understanding because we did not discuss it in the class, then I will, consider something, okay? All right. Okay, so that's all for today. Any questions anybody has? Yes, sir. Tyler, I might add in more for you. I'm just joking with you. All right.
So I expect. What's that, 1, 2? That'd be okay.
I don't mind at all. If you think you need to explain yourself a little bit more, do it. I don't care. Okay.
That should be different.
Unless you put unnecessary things in there.
Like I said, I should be pretty, 1 or 2 sentences, but I should have schema or.
All right. Thank you all very, very much.